Hello, hello. This is the Cloud Native Hacker, and welcome to the channel where we discuss cloud native security and other related topics. Before we start, a quick disclaimer. This channel isn't affiliated with any employers, past, present, or future. This content is purely for educational and informational purposes only. Always ensure you have proper authorization before doing any security testing. The information provided here is not legal advice. Thank you for joining us. Today we are going to be taking a look at some potential security vulnerabilities with AWS IAM. That's Identity and Access Management. We will look at a few different ways which access can be misconfigured, which would allow for privilege escalation. For today's video, we will be leveraging an open source tool called IAM Vulnerable from Bishop Fox. IAM Vulnerable is a deliberately vulnerable IAM playground which you can deploy to a non-production AWS account. IAM Vulnerable contains multiple escalation paths across many different AWS services. If you find anything valuable in this video, don't forget to show some love with a like and subscribe. Let us know what you'd like to see in the next video. Let us know what you liked about this one. Any constructive criticism is always welcome. It helps me figure out what kind of content you might enjoy, and it helps the video reach a wider audience. For those of you in the security space, I'd be curious to know what sort of things you're doing to proactively identify these types of issues. If you're not in the security space, I'd be curious to know if you've ever thought about these types of exploits. If you'd like to share, leave a comment down below. Alrighty, for this journey, we're going to be using IAM Vulnerable from Bishop Fox. This is an open source set of Terraform modules which would allow you to deploy a vulnerable IAM configuration within an AWS account. These modules have a ton of different paths to escalation, so to keep this video short, we're just going to be looking at a few today. As always, check the links in the description if you'd like to follow along at home. In this video, we will be looking at 3 different scenarios. The first, we'll be taking a look at Lambda. For the second, we'll be taking a look at CloudFormation, and for the last one, we'll be looking at EC2. There are a few policies associated with these services that are misconfigured, and they allow us to gain administrative access from an unprivileged user account. In a future video, we're going to go over some ways that you can harden against these types of things. Let's talk a bit about the scenarios that we're going to be looking at today. For the first scenario, it's going to be a little bit similar to one of the previous videos I did where we attacked a vulnerable serverless application. Here, we're going to be targeting AWS Lambda. The difference with this case is that we are going to be using an existing set of credentials which are lower privileged, and we're going to use those to modify an existing Lambda function. And by modifying that Lambda function, we are then going to be able to elevate our privileges. So whereas the one in the previous video was from the perspective of an external attacker, you can think of this one as an attacker who has already gained some sort of access within the environment, or an internal threat. The second scenario that we're going to look at is using an account that does not have administrative permissions, but it does have the ability to deploy resources using CloudFormation. The template that we're going to deploy is going to allow us to get administrative credentials. And in the last scenario, we're going to again start with an unprivileged user. The difference is with this user, we're going to be able to launch an EC2 instance with an existing instance role. That instance role is going to be our avenue to elevating our permissions. So if you want to get some hands-on experience, feel free to follow along. And let's exploit some holes with a vulnerable IAM setup. For our setup today, we're going to be using the same setup we've been using so far. So I'm on a Windows 10 machine with VirtualBox installed. In VirtualBox, I've got an Ubuntu VM where I've got the AWS CLI installed, I've got Terraform installed, and we'll walk through how you can deploy the IAM vulnerable resources to your account. Our victim in this case is going to be an AWS account that we have. This should not be a production account. These resources, again, are deliberately vulnerable. So make sure that when you're setting them up that you take them down as soon as you need them as well, and you don't have anything sensitive in that AWS account. Okay, so let's go ahead and log into our attacker machine. We're going to go ahead and get a terminal going, and we're going to go ahead and take a look at the repo that we're going to be using for today. So this is the IAM Vulnerable GitHub repo from Bishop Fox. If you take a look, there's actually a ton of really wonderful resources here that talk about all of the different privilege escalation paths, how you can get it set up and everything like that. In our case, because we are leveraging Lambda, EC2, and CloudFormation, we are going to have to set up some additional modules that wouldn't be installed by default. So let's go ahead and clone that repo. Then we're going to go into that folder, and we're going to take a look at this main Terraform file. So by default, you have as you can see here, we've got this Lambda module. So these are commented out, and the reason why they're commented out is because these resources that are spun up will cost you some money. So at this point, if you do want to follow along with the video, Make sure you set up billing alarms and all that. Because there's not a ton of interaction, it shouldn't be too expensive, but it's still something you might want to be careful of. Another thing is you want to make sure that your AWS credentials are set up appropriately before you begin this. I'm not going to be using Glue, SageMaker, but we will be using CloudFormation. Go ahead and save that, and then go ahead and plan this. I already know it's going to happen, so we'll just go ahead and right. That makes sense. We need to init this, so that way we'll pull all the modules that we need. Go ahead and run that. Nope, that happened pretty quickly, I guess, no cut there. And now let's go ahead and create those let's go ahead and create those resources. There are actually a ton of IAM resources that are created, lots of policies, roles, users, groups. So it really is something you want to create in an empty account if possible, and make sure to destroy your resources once you're done playing around. I just wanted to make a quick note. So when I went to deploy the Lambda module, I actually ran into an error where the repo was using a Node.js runtime that was no longer supported. So I made a pull request fixing that and updating the AWS provider as well. If that pull request is rejected or anything like that, I just wanted to show you what I did so that way you can make the changes if you want to follow along. So the first thing I did was just in the main.tf, this was set to the 3.0 branch. I changed this to 4.9 and higher. The reason why I targeted 4.9 is because there were some breaking changes in 4.0 through 4.8. They were able to make 4.9 and above more backwards compatible. There may still be some issues, but at least with the deployment that we're doing today, I didn't run into anything. So after doing that, then you want to go ahead and go into the Lambda Terraform file, and this is the runtime configuration. So this was using Node.js 12.x, which is no longer supported in Lambda. So I just went ahead and updated that to 18.x. With those changes, I was able to get everything deployed successfully. So I'll see you as we dive into some of these scenarios. All right, so let's take a look at the first scenario here. In this scenario, we're going to be leveraging two user accounts. The first user is our attacker. The attacker already has credentials. It's either an internal user or some sort of external party who has gained some credentials. The attacker has permissions to update a Lambda function's code. So the first step is that attacker is going to update that Lambda function. That Lambda function is going to enable the attacker to elevate permissions. The second step is that Lambda function is called. This could be by a normal user, or if the attacker has permissions to invoke that Lambda function, it can be done that way. In this case, the attacker does not have those permissions, so we will be using a different user account. And then finally, that Lambda function is going to add those privileges to the attacker's account. So let's go ahead and switch over here to our attacker. We've got a few files here. Since we are using the Node.js 18 runtime, we've got package.json, which just tells Lambda that this is a module. And then let's take a look at the index function. So here you can see we've got our user, which is privesc17, and then we've got the administrator access policy. So when this Lambda function is called, it's going to attach that administrative access to our attacker. So I've already zipped up those two files in this function.zip, and now we are going to upload that. We're going to update the function here. And after that has finished updating, now we are going to go ahead and invoke that Lambda function. And as you can see here, we're using the Scenario 17 profile. This profile is that Privesc 17 user. In this case here, you see the role associated with the Lambda function. So this Lambda role has the ability to attach policies to users, which is part of the vulnerability chain here. And then we are going to invoke this with a different user account. So let's go ahead and do that. And that succeeds. So let's switch over to our AWS account here so I can show you what happened. So we have our user here, our attacker user here. And now we've got administrative access. So we have successfully used that Lambda function to add administrative privileges to this user. And we did it by updating the Lambda code and then having that Lambda function be invoked. Okay, so for our next scenario, we are going to be leveraging CloudFormation. The issue here is that we have a user who can create CloudFormation stacks as well as describe those stacks. The problem comes that this user can pass any existing role. So what we're going to do in this scenario is we're going to pass a higher privileged role to that CloudFormation stack, and then that CloudFormation stack is going to go ahead and create an administrative user, and we're going to gain the credentials from that CloudFormation stack by describing it. So let's go ahead and take a look at that CloudFormation template. We've got the managed policy for administrative access, and we're going to be attaching it to an administrative user, and we're going to create access keys for that user, and then the CloudFormation stack will output the access key and the secret key. So we've got credentials, so we're going to go ahead and create the stack, and you can see here we're specifying the role that will be passed to the CloudFormation stack. So now we've got that CloudFormation stack created, and next we are going to go ahead and describe the stack in order to get our access keys. We've got an access key and a secret key. Now these should be rotated by the time this video is out. If they're not, let me know. But now we've gone from a user that had relatively limited permissions, except for that IAM pass role, and now we've got full administrative access. So this is just one of the ways to use that type of privilege to escalate to administrative permissions. As you can see here, so we've only got IAM pass role, and then the ability to create stacks and describe the stacks. So I'm going to go ahead now, before I forget, and delete that CloudFormation stack. And let's go ahead and take a look at the users. So admin. So you can see here, this is the admin user. Go ahead and refresh a bit, and that should go away shortly. Okay, and now that user has been deleted along with that stack, and so those keys should no longer work. All right, so let's jump into our last scenario here. So this one is similar to the previous one where we are passing a role. The difference with this is we are going to be passing an existing role to an EC2 instance. So our attacker has the permissions to run an EC2 instance, has permissions to pass a role, but it does not have administrative privileges. The issue here is that we're going to pass that high privileged service role to that EC2 instance. Once we do that, we are going to SSH into the EC2 instance, and then we're going to obtain the temporary credentials from that EC2 instance, and we're going to use those credentials to add our user to the admin group. Okay, so let's switch over to our attacker, and the first thing we're going to do is create an SSH key pair. So we've got our key pair. Let's make sure the permissions are okay. And now we are going to go ahead and launch an EC2 instance with that privileged role. So let's go ahead and launch a new instance here. Now that the instance is starting, we will wait, and then I'll go ahead and get the public IP, and we can SSH into it from there. Okay, so the instance is fully started now, so let's go ahead and grab that public IP. And then we're going to SSH into that. Okay, so now that we are on the machine, we are going to go ahead and use the metadata URL to grab some credentials. So we are, this instance is configured for the version 2 of the metadata API. After we get the token, then we can go ahead and get the metadata. Okay, and now we've got those credentials, so we'll use these credentials to go ahead and add our user to the admin group next. Okay, so now that we got those credentials configured, let's go ahead and add our user to the admin group. And let's switch over to the AWS console so we can take a look at that. So we're going to go ahead and refresh this user. And as you can see now, we've got a group and we've got our administrative access. So with that, we'll wrap up the last of our walkthroughs on these scenarios. Okay, let's recap what we did today. Today we updated an existing Lambda function to give our user administrative access. We created an EC2 instance that had an administrative role, and using those temporary credentials, use that role to give our user administrative privileges. And we also launched a CloudFormation stack that gave us an administrative user. Thank you for joining us today. If you found value in this video and our exploration of exploiting vulnerable IAM configurations, please like and subscribe. Feel free to follow along on Instagram, and look forward to a future video where we take a look at how we can harden some of these types of IAM misconfigurations. Until next time, this is a Cloud Native Hacker signing off.